Hi everyone, a happy morning. I am Aditya and I am here to talk to you about the concept of QR decomposition, which is a powerful tool in linear algebra that helps us break down matrices into meaningful parts. Then we will enter into the applications of QR decomposition and explore their significances and so on. Now let's see in general what is QR decomposition. QR decomposition is a technique that splits a matrix into two distinct matrices Q and R, where Q is orthogonal matrix and R is an upper triangular matrix. Here we have seen that Q is an orthogonal matrix, which is a square matrix whose columns and rows are orthonormal vectors. In simple terms, the rows and columns of Q are orthogonal to each other, that is perpendicular and have unit length. R is an upper triangular matrix, meaning all the elements below the mean diagonal are 0. Now we will see about the importances of QR decomposition. Solving linear equations. Using QR decomposition, linear equations can be solved efficiently rather than using traditional methods like Gaussian elimination. The next one is eigenvalue problems. Using QR decomposition, calculations of eigenvalues can be simplified, which are essential to understand matrices. Least square problems. QR decomposition is numerically stable, especially for least square problems, which rise in data fitting and optimization tasks. Now we will enter into the topic of geometric interpretation of QR decomposition. Orthogonal projection. Orthogonal projection is important to understand the geometry of matrix transformations. Think of Q as representing a set of orthogonal axes. The matrix R contains the length of projections of original matrix columns onto these axes. Geometric transformation. QR decomposition can be viewed as a geometric transformation where the original matrix is rotated and scaled along the orthogonal axis. Then its linear transformations. This geometric interpretation helps to visualize how QR decomposition relates to linear transformation and their effect on vectors too. Now we will see the practical considerations of QR decomposition. Gram-Smith process. This is a common algorithm used to calculate QR decomposition. It involves orthogonalizing a set of vectors. Then the next one is householder reflections. This is another popular technique used to construct the orthogonal matrix Q implicitly while transforming A into R. They involve reflecting vectors across a hyperplane. Computational efficiency. QR decomposition algorithms are computationally efficient, numerically stable, making them suitable for real-world applications. Now we will see the uses of QR decomposition across various fields. In the field of data science, QR decomposition is used to refer the dimensionality reduction, feature extraction, and solving linear regression problems. Machine learning. QR decomposition is employed in algorithms for training the machine learning models such as linear regression, support vector machines, and principal component analysis. Then it's computer graphics. QR decomposition helps in 3D graphics for rotations, transformations, and video projections, contributing authentic visual effects. At last, in robotics, it finds application in robotics for control, navigation, and path planning, enabling robots to perform complex tasks effectively. Now we will see the advantages and limitations of QR decomposition. As we have already seen, it is numerically stable, widely applicable, efficient to solve linear equations, simplifies eigenvalue problems. Then the limitations of QR decomposition are they are computationally intensive for large matrices and it requires careful implementation. Now we will see a small Python program for the implementation of QR decomposition using Gram-Smith process. We are importing the NumPy library initially and defining a function called QR decomposition which takes matrix A as input. A.shape function returns the dimension of the matrix where n is the number of rows and m is the number of columns. The matrix Q and U are initialized using the next two steps as follows. For I in range 1, n. For each iteration I, we consider ith column of matrix A as vector U, which will be modified to form orthonormal vector for Q. For the next three lines, which starts from for j in range I, this computes the projection of ith column of A onto the jth column of Q. In the program for normalization and projection steps are continued. We entered the input statement at the end of the program, which can be also applied at the beginning of the program, which doesn't matter in Python. And finally, Q and R matrices are received as output. We have now entered into the conclusion of this video. QR decomposition is a powerful tool with wide applications in mathematics, computer science, and engineering. As computational resources continue to advance, QR decomposition is likely to play an even more prominent role in solving complex problems and driving innovation across various fields.